Assalamualaikum warahmatullahi wabarakatuh. We are from Group 12 and we will present about our project. First of all, my name is Syahira and I will explain about the introduction. Truss is known as a rigid structure composed of strict members that are connected at their ends. A truss bridge is a load-bearing structure with multiple horizontal, vertical and angle members that are connected to form a triangular shaped frame that only undergoes compression and tension forces. Bridge are structures that assist people and vehicles crossing rivers and oceans, as well as linking communities and cities. The design of the bridge, depending on the function of the bridge, the environment of the location where the bridge is built, the material used, and also the cost to build the bridge. For this project, we will assign to design a bridge based on the existing bridge, where we focus on truss bridge with the dimension was specified as follows as total span length 40 meters, height 5 meters and width 5 meters. This analysis of this project will be conducted by considering the dead load and also live load and carried out by using LECTURER'S software and manual calculation, which is using alternative method to calculate the internal forces, virtual forces and also deflection for truss bridge. The objective of this project is first to apply and practice structural analysis knowledge, second to make a comparison for the result of the manual calculation and the calculation done by using software Pro, and the last one to participate in a group project and work as a part of team. For the problem statement, excessive reflection on the bridge deck when subjected to moving vehicle loading or walking people is one of the most critical or dangerous aspects of truss bridge structures. Truss bridges come in variety of shape and sizes, hence the degree of determinacy of bridge structure has to be calculated. The type of bridge truss to be considered will have an impact on the bridge structure when the bridge deck receives the loads and distributed them to the ground. In this project, the internal forces and deflection of the truss will determined by using LECTURER'S software and manual calculation, which is alternative method. The result will be compared to know the error and also difference between the calculation by using LECTURER'S software and also manual calculation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farah Huwaini, Binti Ridzuan. Membership number is DF 200-134. For design of a bridge, we choose this kind of layout design. This layout we'll call as truss. So the truss design is a very popular design for both rear and model design, and it was used in California, United States of America. The bridge was designed for public as a roadway.
Assalamualaikum warahmatullahi wabarakatuh. My name is Athirah Iliyani Binti Rani and my matrix number is DF 200149. Before we proceed to the calculation of internal forces, we need to convert the distributed load to the point load. There are a few steps. Firstly, the dead load, which is the self-weight of concrete pavement. All the information is using GKR specification. Next, the live load, for example, 2.5 ton for each car that moving. Lastly, the self-weight of beam that contain of width 5 meter. The height is 5 meter and the length is 5 meter. And the last one is incline is 7.07 meter. This information is using 610 multiply 305 multiply 149 of beam dimension. I will be presenting about the method that we decided to use for manual calculation, which is alternative methods. It is more easier than methods of joint and methods of sections. Firstly, draw the FBD of the structure and then determine the determinacy of the structure. The third step is solve the reaction of the support A and I. Then to get the internal forces, we need to make sure they are balanced. Lastly, tabulate the value of the forces and then determine whether it's compression or in tension. Firstly, we need to calculate the members, the joints and the reaction of the structure. And then we need to make sure that the members plus the reaction equal to 2 joint. So the value that we get is 29 equal to 29, which is statically determinate and stable. So it is proved that because the support is pin and the roller. So for the manual calculation, we use the alternative method. So we can see that the reaction for AY and IY is 1297.11 kilonewton and it is in upward condition. So let's move to the interesting part, which is manual calculation. The joint A for the detail of manual calculation. AY is upward and the equal member of the 15 need to be downward to make it balance. So we get value for the member 15 is 1627.77 kilonewton.
Okay, now for methodology of LECTURER'S software. So for the step 1, we plot the joint according to the proposed design. Then connect one joint to another joint to become a member of the structure using LECTURER'S software. And the step 2 is add the support reaction, which is pin support at joint A and roller support at joint I. And after that, apply the proposed live load and dead load into the bridge structure. For the step 3, we choose run static analysis from the drop down menu. And the last step is the reaction at support, shear force diagram, moment diagram, and shear force diagram, and deflection line are showing in tabulate static analysis result as attached in our appendix. For the software calculation, in order to get internal forces of this kind of design that we choose, so first we need to include the dead load, which is the weight of concrete pavement, which is the value that we get from the manual calculation, which is 42.19 kilonewton per meter. and for the live load, which is the moving vehicle load that we get, which is 2.76 kN per meter. We also get our self weight of beam in manual calculation that we must include in our LIMPRO software to get internal forces to total out with dead load and live load, which is self weight beam, which is width, height, along, and the length of the structure.
My name is Nurhana Binti, the F200-147. For methodology of deflection calculation, the first step is to determine all forces in truss member due to external load. Then, replace the external load with 1 kN at joint E in the vertical direction. The final step is to find the deflection value. For the deflection by manual computation, the first step is to find the support reaction at both support A and support I by using an equilibrium equation. The next step is to multiply the length, force, and rotor force for each member. Then, sum up the multiplication. The next step is to multiply the value of Young modulus E and beam area A by assuming E is equal to 200 gigapascal and A is equal to 0.186655952 meters squared. To get the deflection value, the summation of multiplication of length, force, and brutal force is divided by the multiplication of Young modulus E and beam area A. The value of deflection by manual calculation is 0.005878 meters.
As you can see in the figure above, this is the result of deflection line that we get using LIMPRO software. That the deflection that we get, which is 0.016879 meter.
This is the comparison data between manual calculation and software calculation. We can see the difference, but it's not too much.
After both calculations of manual and software have been finished, the values will be compared to get the differences and percentage error value. To get the differences, subtract the manual calculation force with the LIMPRO software analysis, while to get the percentage error, subtract the exact value with the approximate value, then divided by the exact value, then multiply with 100%. Since the deflection value from manual calculation is 0.005878 meter, while from software analysis is 0.016879 meter, the value of differences is 0.0011001 meter, with the percentage error of 6.52%. For the discussion, the bridge design is inspired by the Truss bridge with the specified dimensions of 40 meter total length, 5 meters of height, and 5 meters of width. The deflection by manual computation is 0.005878 meter, while the deflection by LIMPRO software is 0.016879 meter, with a discrepancy of 0.0011001 meter acquired from both calculations. The percentage error is 6.52%, and this error is accepted since it is lower than 10%. For the recommendation, the study findings can be used as the basis for conducting the future studies of structural analysis of a truss bridge. The following recommendation can be suggested for the use in future studies, such as improve the design of the truss bridge by increasing the members of truss bridge, as it could help to reduce the tension and compression forces that hold by a member. The quality and effectiveness of construction technique also should be emphasized because they will determine how the bridge perform under the loads. Furthermore, the material used for the truss bridge should be chosen carefully depending on the function of the bridge to ensure that it can save the cost to build the bridge, as well as to ensuring that the construction will not fail owing to the material chosen. Next, the safety of the current bridge users can be improved by widening the bridge. The current structure bridge, lane width, shoulders, pedestrian, as well as bicycle access can all be enhanced by removing the concrete deck, partially or completely, in order to widen the current structure. Last but not least, it will be necessary to proficient in using engineering software such as LIMPRO software in order to ensure that the analysis can be carried out properly. Other than that, it also required to use the LIMPRO software to reach the manual calculation method if there is error occur. Therefore, if the errors occur are influencing the result, it is better to redesign the truss bridge carefully and review each step of the procedure for potential sources of error. For their conclusion, the details of the design and planning of a bridge has been learned. Engineer must verify that the bridge is secure and protected for anyone to use. To ensure the safety of the bridge, it must be examined and evaluated. All of the standard for bridge design and planning has been satisfied. The objective of this project has been fulfilled. The bridge design and calculation has successfully demonstrated. The calculation outcome of the manual and software LIMPRO calculation can be compared, and the utilization of LIMPRO can be learned, and dealing with such future project will be simpler. Okay, that's all from us. Thank you.